Thank you so much. All right. Um, hopefully, I will try to give you as much helpful and real-world information as possible. We are working with real projects. So therefore, whatever I'm going to be saying is what we have seen working or not working on real projects. Right, let's start. So first of all, it doesn't make sense to just talk about a generative AI in a vacuum, right? We need to see what problems do we have, what problems does generative AI can solve us, can help us to solve, and to what degree, right? At this point, of course, I'm gonna take over and do everything for us. And the software systems which are being tested are pretty complex usually, right? We don't test just simplistic public websites out there. We usually test complex software. And from that perspective, I will be talking. My background is actually almost always being the B2B software. So when I'm talking about software, what usually I have in mind is forms, tables, graphs, diagrams, this kind of software. All right, so what are the challenges? Well, first of all, I would like to establish that hopefully we are all on the same page that as an organization, key organization for your company, we want to build as much automation as is technically possible and makes sense. The reason for that is just speed, right? In order to be able to empower the SDLC to be able to move faster, this is why we build automation. This is basically the reason to do it. However, there are challenges to build this automation, and those are like four, probably the largest one. So first of all, the speed of building automation is very, very slow. It's extremely hard to start. If you don't have anything, like there is a lot of setup, especially for mobile, it's just obscenely hard usually. And then after that, what we have seen when we asked our customers, hey, how quickly do you build tests? How many tests we have, so on and so forth. The results are not very good. Like we'll do this exercise in a second. Then the second, probably actually the largest challenge is test maintenance. The more tests you build, the more you need to maintain. Again, we'll chat about that. And the SDLC, majority of people you're probably using right now in the company is actually shooting you in the foot and eating just the process, eating up around 30% of your bandwidth because it's unoptimized. Moreover, the new trend on new thing that we need to do in order to more and more in order to do the testing is we need to test the features that use generative AI. It could be as simple as an AI-enabled chatbot, or it could be some kind of complex summarizations, graphs, and so on and so forth. And right now, basically, people are writing them off as untestable or unautomatable, right? People just do it manually. However, the amount of these features will be significantly growing over time. At this time, based on the report, already 85% of all companies are using generative AI for their features one way or another. So the just using is just the start, of course, and the amount of this use clearly will be growing over time for sure. And think about it, if the amount of these Gen AI based features will be growing, we need to figure out how to automate it, because otherwise we will be drowning in manual testing. All right. Well, speed of building test automation. Needless to say, the companies just who were not quick enough, like they couldn't had really big fallout for them. And think about it, the amount of stuff CrowdStrike need to test is huge, and they just didn't get to certain parts of it. And then that's it. We just got very unlucky in a sense, for folks. But point being, it talks about this exact problem, right? You need to be delivering the software fast to production, and there's just not enough time to do it manually. And if you do not have enough automation, things like this are happening. There is actually a metric that you can use to track, and some company actually tracking it. It's called like I'm blanking out what's the name of the metric, but the point is it's number of bugs released to production for 100 features that have been released. So you can calculate, okay, per 100 features that we have released, this is the bugs that were found by our customers, and this is a metric that you should track, because it affects the business and affects the churn, basically. And the name of this metric is called defect escape rate. You can Google it up. Like this is the number one metric, right? Because if you think about it, the goal of QA organization as a whole is preventing bugs from being able to get to production, and that's one of the KPIs you could use to get there. Now, I would like us to do the exercise, right? You can do it in your head, or you can do it pen and paper. We will be estimating, currently you can estimate the speed with which your current team are building automation. And it's very, very, very straightforward. So first of all, we will calculate time spent is actually number of man years that your team already spent building automation. It's very straightforward. It's number of people times number of years we have been building automation. There's a nuance to that, but you can probably imagine how many man years have been spent building automation, right? So remember that number. So it's time spent in man years. And now you probably have roughly in mind the number of automated test cases that you have, right? So how many test cases you have automated, and therefore it's very easy to calculate the speed. It's number of those automated test cases divided by number of man years spent to build those test cases, and that gives us basically an average speed. How many test cases a person in your organization builds per year on average, right? So it's the amount of all automated test cases divided by how many years have been spent building those. And you can basically imagine like which category did you get into, but point being is one of the advantages that generative AI provides is that, or we would want it to give us, is ability to help us to build automation faster, right? We all want to get to this green territory where we build automation quickly enough. And next thing is actually significantly more dire. test maintenance. And I guess I will get to example first. Can you guys see anything on the screen, or should I turn off the light in here? It's like where's the Selenium script there? Can you see that? No, okay. So let me see. Is it better now? All right, great. Basically, this is to illustrate the problem. I want to basically dissect with Selenium scripts. Very simple Selenium script. What it does is login. It finds 3 elements on the screen, the two input boxes and a button, and fills out username, password, clicks commit, and then gets and on the screen finds an element and validates it contains welcome Peter. So that's a login test, right? Somebody might write first. So clearly, it has a lot of challenges in here. So and imagine almost immediately, probably tomorrow, the first thing which will break is, of course, this ridiculous XPath, because engineers, of course, will refactor stuff. They will insert additional divs somewhere in there, and that's it. The code will be broken. Well, what does that mean, right? That means that our login test is broken. Engineers claim everything is working fine. So we starting the application, going in, finding yes, it's working fine. Okay, what's going on? Seeing, hey, this is a line that is broken. We need to find the new XPath, update the test, find we are moving on. Next thing is button got renamed because, well, right now it says commit, but actually the engineers renamed it to login because commit is all over the place. It's just we're doing a cleanup. Again, exactly same thing. Can't find the button, can't log in. Engineers claim everything is fine. Manually we tested, everything is fine. But it doesn't work. So we need to find, okay, so like login is no longer can be found. There is no such button. The button's new name is this. Commit, sorry, couldn't be found. The button's new name is login. Next thing is, of course, engineers will do cleanup. And cleanup is ridiculous ID because it shouldn't say user underscore email underscore login. That's excessive. It should just say user underscore email, right? Because login is implied. Of course, where you would do it as a login, or at the minimum, you put L into lowercase, right? So that would be cleaned up again. What does it mean? Bam, again, test broke. Again, the same process, manual testing, the finding what's going on, finding the new locator, new ID in this particular case, and so on and so forth. And at the same time, the manual tests have been working perfectly fine, right? We can execute these instructions, no problem. It's fine, it's working fine. However, we invested a lot of time into fixing this Selenium script. I wanted to point out a couple of things in there. So number one, like notice the whole process, right? What were we doing? Instead of doing the engineering work, we were de facto doing manual testing. Because if it's broken somewhere, the first thing you would do is just, okay, so the test is broken. We need to validate is actually broken or not. Is it a script or is it our stuff? We need to at least get to the place where it's broken to find the locator at a minimum. So therefore, the QA automation engineers, instead of doing QA automation as they're supposed to, instead are doing manual testing. Like that's just not making any sense. Not only that, but basically the overhead was gigantic. There's a lot of changes for no particular reason, even though like if we were to test this login manually, it would have been working perfectly fine, right? And that gets me to a point of the how to use AI. It matters. So if you're trying to use generative AI naively and say, hey, like such and such, let's generate me a Selenium script for my login, and maybe like there is a system which will go through and will help you to build that Selenium script. Well, you're shooting yourself in the foot because it's not going to help you. You can generate yourself 10,000 end-to-end test cases. Well, first of all, it's not going to do it anyway. It's not the AI is not on that level yet. But they mentioned you could do it, and you would generate 10,000 tests for yourself. When tomorrow, like 5,000 of them will be broken, you won't even have enough time to fix it, right? The overhead of fixing these tests will be so gigantic, they will be basically useless. So the value, therefore, is not in generating the Selenium test. There is a different approach, and that's AI agents. That's a new thing. You hear, I guess, probably next year about it all over the place. But the next thing is AI agents. What AI agents do is they use generative AI, but they give a generative AI legs and arms, basically. So they enable generative AI to do stuff on its own, in a sense. So why it is significantly better concept in this particular case and what I'm talking about. So imagine that if generative AI can literally just read the manual test case and execute it for you, then it's not only that you get the benefits that, hey, like here's automation, but also you don't get the downside of a huge maintenance overhead. And the maintenance overhead is actually pretty gigantic. Based on, again, on our research with a lot of companies, we have noticed that at around 300 end-to-end tests that involve UI, it is full-time job to just maintain the tests. The 300 end-to-end tests will consume 100% of your engineering time of one engineer just to maintain the tests. And that basically makes it unscalable, right? So you can't scale it. So like you mentioned, there's the team. If you are a manager, there's only that number of team members you can afford to hire. And once they own on full-time on test maintenance, nothing you can do, and all of your automation efforts stop. Right? This is why it is unscalable. So this is why it's important to a little bit shift concepts and not only use generative AI to help with test offering, but also get its help to almost eliminate as much as possible the test maintenance. Okay, so where is the benefits basically coming from? I think they should be more or less self-explanatory. The benefits is as the lack of reliance on details of implementation, right? So what are those, the XPaths, IDs, and names and stuff like that? If you think about it conceptually, what are those XPaths, CSS selectors, IDs, dedicated test IDs, and so on and so forth? Those are the details of implementation, how engineers coded the HTML yesterday, as opposed to how it should function functionally from a user's perspective. And of course, if you're writing the code to test how engineers wrote it yesterday, like engineers most probably will change it and refactor it tomorrow. And this is where the overhead of constant catch-up basically will start take its toll. So the problem is the conceptually wrong approach with Selenium, well, same Playwright or Cypress. So you are testing the details of implementation. You're testing the DOM as opposed to testing functionality. Mind you, like for unit test, that's exactly what you should do, but for end-to-end test is definitely suboptimal. All right, so next thing is another challenge is the SDLC process that a lot of, well, basically almost everybody uses. I'm sure once we're talking about it, you'll recognize the challenges. So the traditional process is product managers or BAs write the specification, then engineers write the code, the way we understood it, and then QA automation attempts to build automation for that code. So what's the problem in here? Well, exactly same thing, right? Then you're building QA automation for the code. You're finding out two things. Number one, bugs, and number two, the fact that, hey, looks like engineers understood the specification a little bit different from what most probably product managers meant, right? So what does it mean? Well, guess who is going to change it? The engineers, of course, right? Because product managers want to deliver a certain feature. From their perspective, yeah, sure, we will add probably a little bit more details to specification or come down and clarify, hey, this is what we need to do. But engineers would need to update the code. What does it mean? Basically, you sit in night, all you did so far is manual testing. You did not complete the test automation test.
I just saw a thing on Slack that needed help. I mean, it's 20 minutes ago. Sorry. Okay, good.
Yeah, very good. Thank you. And now engineers deliver a new code. Again, like you'll probably find the bugs. You still couldn't complete the full automation because stuff has bugs. Engineers now fixed their bugs last moment. They were heroes and they were able to fit in a sprint, but QA automation got left out. And now it's the next sprint and you need to build automation for new functionality. And this is another way how automation is constantly being pushed out. And another reason why you can't get to your automation goals. So it's lagging, and it's lagging further and further away because of the process. Imagine you could do it a little bit different, and this is not new. This is called ATDD, Acceptance Test Driven Development. Imagine if you could build automation before engineers write the code. So what's the advantage of it? Well, you will help product managers to clarify the specification before it gets to engineering. And moreover, the tests themselves will be part of specification. They will be executable specification. So they will be just generic specification by product managers, which you will help to clarify, and they will be executable specification, which you would write. This way, well, mind you, of course, when engineers write the code, there probably would need to be changes to QA automation code to maybe adapt ever so slightly to reality. But point being is most probably it will eliminate the need to redo the stuff, and the bugs. And there was a case study with BNP Paribas where have proven that this process actually saved them 35% of engineering time. So the whole organization started to move 35% faster. Moreover, from QA automation perspective, it's significant improvement in quality of life. Think about it. What do you do in the standard approach? You're constantly trying to play catch up. You constantly can't fit, and not because of your fault. It's because of engineering being late and your stuff being pushed out. And then you can't deliver, but it's not your fault. It's because you were playing catch up with engineering. But who is there to blame? Of course, QA automation, because we didn't complete, right? If the process is switched around and QA automation is done before engineers write the code, it's other way around, right? You have the time to build the automation, and then engineers write the code. And then guess what? You could, in theory, keep 100% test coverage automated because you always deliver automation first. Well, of course, there are details to how much automation and so on and so forth, like devil is in details, but you can get basically, in some scenarios, as close to 100% as possible. But most importantly, you'll have your time to deliver, so you will get your bonuses, promotions, and such, and whoever will have to work harder are engineers. So it's definitely a huge improvement in quality of life in there. And getting to that again, remember the AI agents. So imagine if you could use plain English language to build this automation. If you could drop the reliance on details of implementation. The whole reason why people oftentimes can't do automation after the fact is because, once again, reliance on details of implementation. So you're writing the code to validate that the engineers did the stuff certain way. They put their text in this particular XPath, they added this element with this ID into DOM, and so on and so forth, right? So, but the problem is that we have to wait. We can't do anything until code is there. If you drop the reliance on details of implementation, this is where like AI agent can help. Then you can actually write automation before, because there is no reliance on details of implementation. So, well, if you want to make anything automatable, it has to be very precise and specific, right? It wouldn't be like, hey, like just blind blah, let's test this and that. It's not going to work. So it has to be like very specific steps, like everything very well defined and specific in order to work. But still, point being is you can drop the reliance on details of implementation, and this is how you can achieve significant improvements in quality of life. Moreover, if you can write test cases in English, then why wouldn't you just import them, right? So import them, and that's another feature of AI agent. Another way how you can get help from generative AI is generative AI can help you to build automation for your manual test cases. The key word here is to help. I know that maybe some people on previous talks here were very optimistic and made it sound as if it's already happening. This is far from the truth. The AI is not on a level at this point to be able to build complete end-to-end test cases. It's just not, well, to put it bluntly, not smart enough. It's just not smart enough, and it lacks the domain knowledge that you have accumulated working in a company. But most importantly, it's just not smart enough. It's just that. So it will be able to help you anywhere between 10 to maybe 80% in some cases on test case, but almost always it wouldn't be able to complete. So yeah, it will be able to help, but will not complete building it for you. What does that mean? That means that, yes, like sounds great, but there will be work. It's still work. If you think like, hey, AI is going to take over and all this kind of stuff, well, maybe sometimes in distant future, in foreseeable future, it will help, and that's the point. Even if AI is helping you to build automation, and it's just doing 30% of the job, and that should probably be average expectation, well, good for you. You're 30% more productive, right? That's the point. All right, so next thing is AI features, right? So there's more and more AI features, as I mentioned, in the products. Plus, there are actually traditional features which nobody ever tested, period, in here. So for example, this is mortgagecalculator.org, right? You can just go ahead online, check it out. Pretty nice looking thing. Like we can probably test almost everything in here, like using one tool or another. But people almost never test the most important thing, which is the graph, which shows the balance should be declining and eventually reach zero. Like that's the whole point of mortgage, right? You eventually reach zero. Otherwise, what the heck? Like it's infinite mortgage or something, non-existent, right? The point being, and that's the most important thing in here, right? So if you're building, think about it. Imagine that your company building a mortgage calculator. I'm sure a lot of financial companies actually do things like that, and it's important to show the graph correctly. Yeah, sure, like yeah, there is the data and it shows the data below. Most probably you can look it up and so on and so forth. But graphs also should show the right information. And how exactly are we testing it right now? We don't, just manually. That's it. We do it manually a couple of times, goes to production, and then never regression tested. So maybe it stopped getting to zero. Maybe it just started to like fluctuate, do some weird stuff. We don't know because we don't test it. And this is another value how Gen AI agents can help you with, right? So with enough guardrails, because remember, generative AI and hallucinations and all this kind of stuff, but you can put enough guardrails into the system. In particular, ask it huge number of times, asking it like 200 times, for example, right? And picks the majority vote, right? This is one of the techniques you could employ there. So you can make it relatively stable up to like 99.9% of the time using these kind of techniques. You can, and it can see right now. So a lot of the models right now that are there are multimodal, meaning that you can pass the image into that, and therefore you can ask things like, hey, on my page, on the graph, is the balance decreasing all the time, and does it reach the zero, right? And the way to do it is just formulate it as a statement, right? Validate that the balance graph is always decreasing and it reaches zero at the end. And AI will tell you if it's true or not. And again, if you do the appropriate techniques to make it more stable, then you can actually even use it in automation. That's another way how you can do it. That's for the graphs, and exactly the same thing applies to Gen AI-based features, such as summarizations, the chatbots, and so on and so forth. Let me give you an example of a chatbot, right? When you're building AI-based chatbot, the challenge there is the response will vary ever so slightly almost every single time you interact with a chatbot, if it's true Gen AI based, which makes it obscenely unreasonably hard to automate for testing, which is a challenge. However, you do not care. If you step back a little bit and think, okay, so what do I care about in the response from my chatbot? You'll find out is you don't care. It's exactly similar to these details of implementation, right? You don't care how does it phrase the things. What you care about is that, hey, it mentions that I should go here and there to find this information. The response is positive, and blah, 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 all these things that you would want to validate in the response with whatever response should convey. So you should test not the response itself, but what the response conveys. This is the point of it, right? And this way, you can employ exactly the same technique with Gen AI, put appropriate guardrails in there, and basically get the assessment that the statement that you wrote to validate the points that AI on the test is making are true. And this is how you do it, right? For example, I don't know, if you go to bestbuy.com, well, Best Buy probably doesn't use AI. People actually stopped using AI and chatbots because of different issues. Let's imagine we were to use generative AI in their chatbot, and you would ask, hey, how do I find a Kindle on the website? And basically the response you would validate is that, hey, the response is positive, but you can do that. And it gave me the instructions. That's another thing that you want to validate. And number 3, the instruction mentioned, I don't know, like whatever you care about, using search bar or like finding in the structure of the menu or whatever it is, or both, or either or. You get my point, right? So what you want to test, what you care about. Probably the most widely used way I have seen in using generative AI summarizations. I'm sure a lot of companies you work for, you probably have seen summarization already used somewhere. You can employ exactly the same techniques, right? Say, hey, that's summarization. Convey A, B, and C for that text. All right, and that's it.